The same way we have classified alcohols also. If there is only one OH group, monohydric. 2 are there, dihydric. 3 are there means trihydric, and more than 3 if it is there, we call it as polyhydric, right? So you need not write it in form of phenol. It will be benzene, and on benzene you have on the first and second carbon atom 2 OH groups. So it is benzene 1,2 diol. Now what is sodium phenoxide? It is on benzene you will have ONA. So this is sodium phenoxide. Then I am going to acidify it. What you are going to get? You are going to get phenol. OH will be present here. Hello everyone, this is Ambali Unnikrishan from the Department of Chemistry. So today I am back with session 5 of the chapter Alcohols, Phenols and Ethers. So in the last session we studied the reactions involving cleavage of carbon-oxygen bonds in alcohols, right? So dehydration of alcohols we studied. Then how to identify primary, secondary and tertiary alcohol using a test which is called as Lucas test, wherein we are using Lucas reagent, right? And the properties of methanol as well as some uses of methanol as well as ethanol which were discussed in the last session. So in today's session we are going to start with the next part, that is phenols. So alcohols are done, we are going to start with phenols. So first we are going to see what are phenols to an introduction, and then classification of phenols. How alcohols are classified, same way we are going to see for phenols also. Then the nomenclature of phenols and the preparation of phenols. So as I told you in the first session itself, how we are going to discuss this, we are going to study the introduction for it, then the nomenclature, then the various methods of preparation, their physical properties, chemical properties. So the same thing will be repeated everywhere, right? So beginning with what are phenols? So these are hydroxyl derivatives, okay? So these are also hydroxyl derivatives. Hydrogen will be replaced by hydroxyl group. So alcohols were hydroxyl derivatives of, yes, alkanes, alkenes or alkynes, right? That is aliphatic hydrocarbons. But phenols are hydroxyl derivatives of aromatic hydrocarbons, aromatic hydrocarbon in which OH group or groups is directly attached to the benzene ring. It is also known as carbolic acid. So as you can see, this is a benzene ring. Okay, one hydrogen which was present here is being replaced by a hydroxyl group. So this is called as your phenol. Okay, so I hope it is clear. Right. Now the classification of phenol based on the number of hydroxyl groups directly attached to the benzene ring. Phenols can be classified as monohydric, dihydric and trihydric phenols. The same way we have classified alcohols also. If there is only one OH group, monohydric. 2 are there, dihydric. 3 are there means trihydric, and more than 3 if it is there, we call it as polyhydric, right? Now in phenols, the hydroxyl group is attached to the sp2 hybridized carbon atom of the benzene ring. So that is also a difference between what? Alcohols and phenols. In alcohols, for example, let us take methanol, CH3OH. The hydroxyl group is attached to this carbon atom. This carbon atom is sp3 hybridized. As you can see, it is further attached to 3 hydrogen atoms as well as this OH group. So, what is happening? This carbon atom is sp3 hybridized in case of what? But in case of phenols, it is attached to a sp2 hybridized carbon atom. So, this is a phenol which is shown here. As you can see, this carbon atom is further attached to 2 other atoms. So as you can see, this is a carbon atom which is further attached to 1, 2 and 3. 3 other atoms. So it is sp2 hybridized. Okay. So now the first one is monohydric phenol. They contain only one hydroxyl group directly attached to the benzene. So this is phenol, which is an example of a monohydric phenol. The next one is you have CH3, that is one methyl group is also attached as a substituent. So as you can see here, this is the first carbon atom wherein which the hydroxyl group is directly attached. This is your second carbon atom. So what would be the name? We are going to study the nomenclature, but still what would be the name of this? On the second carbon atom, you have a methyl group. So it will be 2-methyl, and what is the principal chain here? It is phenol, right? This is phenol. On the phenol and the second carbon atom, you have a methyl group. So it is 2-methyl phenol. That's it, right? Okay. So when you have on a benzene ring a hydroxyl group as well as a methyl group, it is also called as cresol. It is called as cresol. Now, this is orthocresol. Now, why it is orthocresol? On the ortho position of the hydroxyl group, you have the methyl group. So, this is called as orthocresol. Now, moving on to this one. Okay, here also only one hydroxyl group is there. So, what it is? It is monohydric. Here also one hydroxyl group is there. So, this is also monohydric, right? Now, the next one is dihydric phenols. Two hydroxyl groups will be there. So, as you can see, 1 and 2, two hydroxyl groups. Here also 1, 2. Here also 1, 2. So, this is quinol, this is resorcinol, and this is catechol, which are the common names. IUPAC name, how to name it, we will be discussing in the upcoming slides. Okay. So, this is compounds containing two hydroxyl groups. Next one is trihydric phenol. As you can see, 1, 2, 3. Here also 1, 2, 3. Here also 1, 2, 3. So, this is called as what? Trihydric phenols, right? Now, nomenclature of phenols. Moving on to the naming of this phenols. So, the hydroxy derivative of benzene is phenol. Okay, hydroxy derivative of benzene. That means in benzene, one hydrogen is replaced by an OH. So, it becomes phenol. The word phenol is both the name of the specific compound and of a family of compounds. Okay, so phenol is the name of that compound. Which compound? This is called as phenol. Okay, on benzene you have an OH group. This is called as phenol, and it is called for the whole family also. Now, the substituted phenols are named as either a derivative or phenol or by common names. So, as already we know, it can be named on basis of phenol. That means you can add the prefixes and then finally end it with phenol, or else you can use the common names as well. In common system, ortho, meta and para are used. For example, in here, these two are the ortho position, these two are the meta position, and this is the para position, right? So, that is used in the common system, not in the IUPAC system. In IUPAC system, the substituted phenols are named as phenol derivatives. When naming compounds as phenol derivatives, the carbon containing the hydroxyl group is always carbon number 1. Okay, so when you are numbering, you are already familiar with nomenclature. So when we are numbering the carbon atoms, of course, the carbon atom which is having the hydroxyl group should be numbered 1. Then the substituents will be considered according to their priority. If there are 2 or more additional substituents, each must be numbered beginning at OH group and going in the direction that gives the substituents the lowest number. Okay, we will discuss that. The di and trihydric phenols are named as benzene diols and triols. If more than one hydroxyl group is there, you need to end it by diols or triols. Okay, so let us name this. Of course, we already know that it is phenol. The common name as well as the IUPAC name is phenol. Now, we have discussed already this, that is, if you have a methyl as well as OH, it is called cresol. Now, the common name will be what? Orthocresol, right? These are in the ortho position. If this is the first carbon atom, this is the second carbon atom. So, of course, this is in the ortho position, right? Now, based on IUPAC, I can't use orthocresol. So, how do you name according to IUPAC? On first carbon atom is the hydroxyl group, second carbon atom you have a methyl. So, 2-methyl you will write. What is the rest of it? It is phenol. So, end it with phenol. Now, how do you number it? This will be 1 again. So, 2, 3, 4, 5 you can number, or else 2, 3 you can number. So, which order should I use so that the substituent will get the lowest number? So, it will be 2, 3, 4, 5 and 6. So, on third carbon atom you have a methyl group. So, 3-methyl phenol it will be, and this is metacresol. Now, why it is that? These two are ortho, these two are meta, and this is para according to the hydroxyl group. So, this is metacresol. Now, moving on to the next one, how do you number again? 1, 2, 3, 4. From either side it will be 4 itself, right? So, this is paracresol opposite to each other, right? So, it is paracresol, or else IUPAC it is 4-methyl phenol. Clear? So, this is simple to name. So, ortho, meta, para can be used in common system, right? Now, moving on to the next one, you have 2 hydroxyl derivatives. Okay, so of course you know diols should be used. Okay, so what is the common name of this? In ortho positions you have 2 hydroxyl groups. It is called as catechol. Okay, now how do I name it according to the IUPAC name? It is benzene. So what is the principal chain? It is benzene, and on the first and second carbon atom you have 2 hydroxyl groups. So you can write it as benzene 1,2 diol. So this diol stands for 2 hydroxyl group. So you need not write it in form of phenol. It will be benzene, and on benzene you have on the first and second carbon atom 2 OH groups. So it is benzene 1,2 diol. So what will this be? 1, 2, 3, or else you can number 1, 2, 3 also, it will be the same. So this will be benzene 1, 3 diol, right? So this is called as resorcinol. When two hydroxyl group are in the ortho position, it's called catechol, and when both of them are coming in meta position, it is called as resorcinol, and when they are in para position, it is called as quinol according to common name. Now this is 1, 2, 3, 4. So 1, 4 diol will come. Benzene 1, 4 diol. Now moving on to the next one. So here you have two methyl groups. So from where should I start numbering? Of course, hydroxyl group should get the first carbon atom. So you can number in this way or this way. It will be same. 1, 2, 3, 4, 5, 6. So on the second and sixth carbon atom, I have 2 methyl. So it is 2, 6 dimethyl phenol, right? Okay, it is phenol. Now moving on to the next one, which will be triols, right? Triols, because 3 hydroxyl groups are there. So what will be the IUPAC name? According to this one itself, we can say it is benzene 1, 2, 3, 4, 5, 6, right? Benzene 1, 2, 3. On the first, second and third carbon atom, you have triol. So benzene 1, 2, 3 triol. Now how would you name this? It will be 1, 2, 3, 4, 5 and 6. So it will be again benzene 1, 3, 5 triol. Okay. So it is simple to name the phenols according to the IUPAC nomenclature. So I hope the naming according to IUPAC is clear for you. Now moving on to the preparation of phenol. So the first method is from benzene itself via sulfonation. So what is undergoing sulfonation? Benzene, right? In this process, benzene is converted to benzene sulfonic acid by treating it with oleum. Okay, oleum we are going to use. Oleum is H2S2O7. This is oleum from which we are going to do the sulfonation. So sulfonation will happen, benzene will form benzene sulfonic acid. Then the benzene sulfonic acid is converted into sodium phenoxide by heating with molten sodium hydroxide, and acidification of this salt will give you the phenol. Okay, so this is your benzene. First what we are going to do? We are going to do sulfonation. Oleum H2S2O7. Using oleum, we are going to do sulfonation. What you are going to get? Benzene sulfonic acid. SO3H will be added. Benzene sulfonic acid you are going to add. So in the first step, sodium hydroxide is added. Then we are going to acidify it. So those two steps are written together here. So as you can see, benzene sulfonic acid will be formed first by the sulfonation of benzene. Now to this, as the first step, I am going to add sodium hydroxide, which will give me sodium phenoxide. Now what is sodium phenoxide? It is on benzene you will have ONA. So this is sodium phenoxide. Then I am going to acidify it. What you are going to get? You are going to get phenol. OH will be present here. So what you are going to get? Phenol will be obtained. So phenol will be obtained. Both steps are written here together. So this is the first method of preparation from oleum by sulfonation. So moving on to the next method of preparation, that is from diazonium salt. So already we have discussed what is diazonium salt, how to prepare that in the previous chapter also. So a diazonium salt is formed by treating aromatic primary amine. So which amine we are going to use here? Aniline we are going to use here. Okay. With nitrous acid, NaNO2 and HCl at 273 to 278 Kelvin. This process is called as diazotization. Diazonium salt will be formed first, and then we are going to hydrolysis. That means we are going to add water to phenols by warming with water or by the treatment with dilute acid. Okay. So first we are going to form diazonium salt. To this diazonium salt, we are going to add water. By warming it, we are going to form the phenol. So this is aniline, to which HCl and NaNO2 is going to be added at 273 Kelvin. What is going to be formed? Diazonium salt is formed. Benzene diazonium salt. So what is this bond? You can see here, it is actually what? It is N2 plus and Cl minus, right? Cl minus, and NaCl and H2O will be formed as byproduct. So to this benzene diazonium salt, what will happen? Now to that water is added and heated. So what will happen? This N2O will be removed as nitrogen gas, and what will be there in H2O? What is there? O and H will be there, which will be attached here, which will form the phenol. One more hydrogen will be there, right? That will combine with the Cl and form HCl. So this is how phenol is formed. Moving on to the last method, that is by the oxidation of cumene by air. Okay, oxidation. In this method, cumene. What is cumene? Isopropyl benzene. So as you can see on benzene, you have CH3CH3. This is isopropyl benzene. You can also write it in this format. That is, you have benzene. You have C here, one CH3 here, one CH3 here. Okay, this way also you can write. The same thing is being written here also. One CH3 is mentioned above. That's it. So this is isopropyl benzene, which is called as what? Cumene. It is called as cumene. Okay, so it is oxidized in the presence of air to cumene hydroperoxide. Cumene hydroperoxide is formed first. Now that is converted to phenol and acetone by treating it with a dilute acid. Acetone, a byproduct of this reaction, is also obtained in large quantities in this method. So this method can be used for the preparation of acetone as well as phenol. So both of these are produced in higher quantities. So what you can see here, this is your cumene, CH3, CH3, and on benzene. So this is isopropyl benzene. So to this we are going to oxidize it in presence of air. So what you are going to get? Cumene hydroperoxide. So what will happen here? Oxygen will be added. We are oxidizing it, right? So OO will be added and hydrogen was already here. O2 will be added. So what you are getting? CH3C, CH3OOH. Okay. So cumene hydroperoxide is formed. Now in the next step, what you are going to do? We are going to acidify it. So what you are going to get? As you can see here, this OH will be attached to the benzene. Okay. That will be attached to the benzene and you will get phenol. Now what is left behind here? CH3, COCH3. That is acetone will be formed. Okay. CH3, COCH3 and OH will be attached with the benzene. You will get phenol. So this is the next method, that is oxidation of cumene. First cumene hydroperoxide is formed, then acidifying it, you are going to get phenol and acetone. So both can be obtained in larger amounts. Okay. So in the next session, we are going to study the physical as well as chemical properties of phenols. So I hope the nomenclature, classification and the method of preparation of phenol is clear for you. So that's all for today. Thank you.